Hey everyone, this video will cover the mathematical concept of the dot product and related practice problems. The dot product is a form of multiplying vectors. For those of you not familiar with vector math, there are essentially three ways. Vector and scalar, for example a vector ABC multiplied by a scalar constant k yields the vector AK, BK, CK. There are also two forms of vector-vector multiplication, the dot product and the cross product. This video will be covering the first of these forms. The mathematical definition of the dot product is given two vectors a and b. A dot b equals the magnitude of a times the magnitude of b times the cosine of the angle between the vectors. In layman English, the dot product relates two vectors and the angle between them. It is a product of two scalar quantities, and therefore produces a scalar answer, the magnitude of one vector and the magnitude of the projection of the other vector onto the first. Let's analyze the mathematical formula. Both sides are scalar quantities. Let's see why this is. The left side says that for vectors of arbitrary length n, a dot b is the sum of all multiplied pairs of corresponding vector parts, that is a1 times b1 plus a2 times b2, etc., etc. The right side is illustrated by the diagram below. It is a product with the magnitude of vector b and the magnitude of vector a projected onto b, which is a cosine theta, where theta is the angle between the vectors. There are three basic dot product identities we should know. 1. A dot b equals b dot a. 2. The scalar constant c times the quantity a dot b equals ca dot b. And 3. The quantity a plus b dot c equals a dot c plus b dot c, aka the dot product is distributive. There are useful variations of this formula. For example, if the vectors are known, you can find the angle between them as shown. Secondly, dividing both sides of the equation by the magnitude of b yields the relation that dotting a vector a with a unit vector in a desired direction b hat gives the parallel projection component of a in the direction of b. For example, this identity is useful in determining distances, i.e. from an arbitrary plane to a point, and force components, for example work equals force parallel times distance. Thus we have a dot b hat equals the magnitude of a cosine theta. Now let's do an example problem. In a meeting of mimes, mime 1 goes through displacement d1 equals 4I plus 5j meters, and mime 2 goes through displacement d2 equals negative 3I plus 4j meters. What are a, d1 dot d2, and b, the component of d1 along the direction of d2? Now for the solution. Part A. We know that a dot b equals the sum of products ai and bi for I equals 1 to the length n of the vectors. Therefore, d1 dot d2 equals 4 times negative 3 plus 5 times negative 5 times 4, or negative 12 plus 20, which is 8. For part B, we know that we can find the projection by the equation a dot b hat equals the magnitude of a cosine theta, even if the angle is not stated. The diagram below illustrates the vectors. The black line illustrates the projection vector d1 dot d2 hat, which is what we want to find. So let's solve. A dot b hat, or in this case d1 dot d2 hat, equals 4I plus 5j meters dot negative 6.0 plus 8.0 j meters, or negative 2.4 plus 4.0, which is 1.6. Thus the component of d1 along the direction of d2 is 1.6. Now for one last example problem that extends the dot product concept to 3 dimensions. Remember, the same formulas will hold, and applies it to the concept of work. Remember, work is a scalar, defined by f dot the displacement vector d. A force F equals 3I plus 7J plus 7K newtons acts on a 2 kilogram object that moves in 4 seconds from an initial position d naught equals 3I minus 2J plus 5K meters to a final position df equals negative 5I plus 4J plus 7K meters. What are A, the work done by F over the interval, and B, the angle between d naught and d final? For part A, the solution is shown and should be self-explanatory at this point. Note that the displacement vector d equals d final minus d initial, or negative 5 minus 3I meters, 4 minus 2J meters, and 7 minus 5K meters, Thus, the work done equals 3 times negative 8 plus 7 times 6 plus 7 times 2, which is 32 joules. For part B, to find the angle between d naught and d final, we simply plug into the variation formula shown earlier, or theta equals arc cosine A dot B over the magnitude of A times the magnitude of B. The same formula follows suit, just with added vector parts. Doing the arithmetic, we see that the angle between the vectors, note that this is an angle in between the vectors in 3 space, is 80.15 degrees. This concludes my tutorial on the dot product.